In our fifth lecture video on the properties of matter, we will continue discussing some details about stress. We will first take a look and talk about the 5 basic types of stress. The first of the 5 types of stress is tension. Tension is where a pulling force is exerted by each end of a one-dimensional object. Tension will cause the object to become longer and thinner unless the elastic limit of the solid has been reached, in which case the one-dimensional object will break. An example of tension would be tug of war. In a tug of war, you have 2 people or teams at opposite ends of a rope applying a force in opposite directions. The second type of stress is compression. Compression is the opposite of tension. In compression, you have 2 forces acting on a one-dimensional object, but the forces are acting towards each other instead of away from each other like in tension. An example of compression might be any kind of supporting column. The weight force is acting in one direction and the normal force is acting towards the weight force. Another example would be compressing a spring. The third type of stress is torsion. Torsion is the twisting of an object due to 2 applied torques acting in opposite directions. An example of torsion would be a screw or a bolt as it is being tightened. The wrench or screwdriver would be applying a torque in one direction, and the medium that you are putting the bolt or screw into would be applying a torque in the opposite direction. Another example would be wringing out a sponge or dishcloth. The fourth type of stress is shearing. In a shearing stress, the forces are applied in opposite directions on the same plane. An example of shearing would be a scissors. You have the 2 blades applying forces in opposite directions in the same plane. The fifth and final type of stress is bending. Bending actually consists of both tension and compression. You have compression on the top in this picture because the 2 forces are acting on a one-dimensional object towards each other, and there is tension on the bottom in this picture because you have the 2 forces acting in opposite directions on a one-dimensional object. An example of bending would be a closet rod sagging under the weight of clothes on the hangers. The top part of the rod would be under compression and the bottom part of the rod is under tension because it is being pulled apart. Now that we have discussed the 5 types of stress, let's briefly define strain. Strain is the deformation of an object due to an applied force. Strain is a direct and necessary consequence of stress. In this picture, we see the strain on the bridge. The bridge is being deformed or bended downward in the middle as compared to if there were no deformation of the bridge, represented by this blue line. Now that we know the basics about stress, let's take a look at a stress-related example. A piece of steel rebar in a bridge has a cross-sectional area of 1,450 millimeters squared and supports a weight of 3.75 times 10 to the third newtons. Find the stress. First, let's write down all of the data we are given. We know the cross-sectional area is 1,450 millimeters squared. We will need to convert this in a minute. We also know the weight force the rebar supports is 3.75 times 10 to the third newtons. We are trying to find the stress S. Before we can find an equation, we need to make sure that our cross-sectional area is in square meters, not square millimeters. To convert square millimeters to square meters, we will first write 1,450 square millimeters as a fraction over 1. We will use the conversion factor that there are 1,000 millimeters in 1 meter. Since we originally have squared millimeters, we are going to square both the numerator and the denominator. This means that 1,450 square millimeters is equal to 1.45 times 10 to the minus 3 square meters. Next, we can write down our basic equation. The basic equation is that stress S is equal to the force F divided by the cross-sectional area A. Last, we can substitute in the data we were given. S equals 3.75 times 10 to the third newtons divided by 1.45 times 10 to the minus 3 meters squared. This gives us an answer of 2.59 times 10 to the 6th newtons per square meter, or 2.59 times 10 to the 6th pascals. This concludes our 5th lecture video on stress.